Okay, today we'll start with the new module that is called the fourth module, input output organization. Input output organization. In this, we'll study the how the inputs and devices and the output devices are connected to a one another with the even the connected to the processor also. How they are communicating with each other. Okay, there are number of input output devices that are to be controlled by whom? The processor. The processor. Okay, these are the input devices. Example: keyboard, mouse and sensor. Keyboard, mouse and sensor, and also switches. Okay, these are the input devices, and the output devices are what? The monitor, speaker, printer, digital display, monitor, speaker, printer and digital display. How they have been connected to one another? Okay, with the help of with the help of the buses. Okay, the variety of IO devices are used to exchange the information from the input devices to the output devices through what? The simple buses called as the buses. These are the connected to the input devices are connected to the processor, and even the output device is also connected to the processor. Okay, how the information will be exchanged from the input devices to the processor, and also processor to the input devices, and the processor to the output devices and output devices. Okay, how they have been interconnected to each other, we'll see one by one. Okay, the main purpose of the connecting the input devices and the output devices to exchange the information between the input devices output devices through the processor. It means here we have the different word length of the word length. Okay, we have the different word length. Okay, based upon the different word length, will be exchange the information between the input devices and to the output devices through what? The processor. This if you have the good different word length means what? If you have the high word length means what? If you have the 32-bit of word length, if you have the 64-bit of word length, then the speed will be different. If you have the higher number of word length, then definitely the information exchange between the input devices and the output devices through what? The processor will be increased with the high speed. That one we call as the this is different speed. The speed of the information exchange between the input devices and the output devices depends on what? The different word length. If you have the high word length, then definitely the speed of exchange the information between the input devices and the output devices will be good. Okay, the speed will be good. Okay, based upon the word length, we have the different speed here. Okay, different speed here. Mainly, computer must be capable of handling these wide variety of devices. Okay, this through what? The system bus. Okay, first we will consider the one of the most repeatedly questions. Okay, explain the access of the IO devices with the single bus structure. How they will be connected to the these devices. Okay, input devices and output devices are connected to what? The connected to with each other with the help of what? The single bus structure. What is the single bus structure? How they are connected? We'll see. This is the one of the question which is the repeated questions, FAQ. Okay, this is all this the mainly the 10 marks they will ask you. The very simple is there. Take the heading as the accessing of the IO devices. Take the heading as the accessing of the IO devices. Accessing of the IO devices. This is very important. This is very simple one, but no. Okay, that's the introduction about the module, complete module. This is about the introduction about the module. Module is mainly concentrating on the input devices and the output devices, how they have been organized to the processor. Okay, the mainly input devices are what? The keyboard, mouse and sensor, and the output devices are monitor, speed, printer and digital display. How these input devices and output devices are connected to each other through what? The buses which will be used. Okay, the mainly the input device and the output devices are connected to the processor in order to get what? The information exchange. Okay, information exchange. The information exchange will be speed. The speed of the information exchange will be depends on the word length of the whatever we are using the the what type of you are using. Okay, if you have the good word length, means what, 64 bit or 128 bit, definitely the speed of the information exchange will be high. Okay, this is the mainly depends on what the word length of our word length of our system. Okay, whatever that we are using here, mainly the input devices and output devices are organized with to the with the processor. This depends on only what the word length of the computer. Okay, now in this also we have the one more first concept is what the accessing of the IO devices. How the IO devices are connected to each other and also accessing with each other throughout the single bus. Throughout the single bus. Okay. The simple figure is there. Just to copy this figure. Processor, memory, and the IO devices are how they have been connected to the single bus. Okay. We'll see. Hmm? ನನ್ನ ಮೊಬೈಲ್ ಇರೋದು ಹಂಗೆ ಅದ ಏನ್ ಮಾಡಕ್ಕಾಗಲ್ಲ. ಏ ಬೇಕಾಗಿಲ್ಲಪ್ಪ. ಹಾ ಬನ್ನಿ. ಪ್ರೊಸೆಸರ್, memory, memory, IO device 1, IO device 2. This is what the system bus. This is the single bus structure. This figure is what the single bus structure. Don't get confused. We have the in each and every module we have the single bus structure. Even we have seen the single bus structure in the what the third module also, but that is different. That is for the different one. This is the single bus structure for the only the IO devices, and also same single bus structure will be same concept will be used, but the in the third module that is allowed, but the depending on the context we have the different figures for the single bus structure. Okay. ಯಾಕೆ ಬರ್ಕೊಳಕ್ಕಾಗಲ್ಲ ಇದು ವೈಟ್ ಪೇಜ್ಲಿ ಬರ್ಕೋಬೇಕು. Okay, this is a very important topic, accessing of the IO devices. Okay, IO devices are usually connected to what the single bus that we call the system bus. System bus. We have the system bus here. This system bus will be connected with the to the all the IO devices, processor, memory, IO devices 1, IO device 2. All these are connected to the one single bus called the single bus structure. Okay, the information exchange between the processor and the IO devices through what happens with the help of what the system bus only. We have the three types of buses are there. We have the three types of buses are there. One we call is the system bus. Another one is the address bus. Another one is the data bus. Okay, the address bus. Okay, the address bus will be if the information. Okay, if the device is want to communicate to the processor, that time the processor has to put the only the address of that particular address of that particular device. Each and every devices will have the its own address of its own address. If you want to communicate to the particular IO device, then we have to give the what the address of that particular IO device. Then if you put the any address of that particular input device on the particular bus, then the particular input devices will be activated through what the particular address. It means what the only the address bus will hold the only address of that particular address bus will hold only particular of that particular IO device address. If you want to the communicate, if you want to communicate with the IO devices through what the read and write operations. If you want to communicate with the read and write operations, then definitely we have to put the control signals on what the data bus. Database is what the bidirectional, but the address bus is what the only what the unidirectional. Address bus was what the unidirectional. So data bus is what the bidirectional. It means what the here the will do the both operations here, the read operations and even the write operations. If you want to communicate with the any devices with the read and write operations, definitely I have to put the control signal. I have to put the signal. I have to put the control signal on what the data bus. The data bus will have the code in the bidirectional. That's what we have the it will do the what the both operation. That's what we have the bidirectional. And also system bus. System bus is also sometimes called as what the control bus. It will control all the IO devices, or it will control all the IO devices. System bus is also bidirectional. System bus is also what the bidirectional. System bus is also bidirectional. Address bus is only what the unidirectional, and data bus is what is also bidirectional. You should remember. And also you have to the if you want to enable the when the processor okay, then okay, for the steps for the exchanging of the information. First step, okay, if you want to communicate with the input devices, if you want to communicate with the input operation, then the definitely we have the some operations here. Only three steps are there. Even the same with the if you want to communicate with the output devices, you have even we also have the here the three steps. Okay, three steps. Okay, one is that the address. If you want to steps for the next is for the steps for the steps for the input in the input operation, and also steps for the output operations. Are you? Okay. Okay, if you want to communicate the address of the system bus holds the address of that particular input device. First it is giving what the address of that particular input device. Okay, if you want to communicate with the input devices, first it is to give the what the address of that particular device, then the control signals. The processor has to send the control signals for this one. The processor has to send the control signal. Then the if I want to communicate with the input device, that has to reach what the first input device has to send the signal, and also it has to communicate with what the one register that is called the data in registers. Okay, data in register. Data in registers. Okay, similarly the steps for the output. If you want to communicate with any IO device, input devices, then the particular input devices address has to send toward the throughout the control signal. Then the control signal has to reach, okay, the particular input devices. Then the particular input device, if you have the keyboard, if you want to have here the input device might be keyboard. Keyboard has also have the one virtual register. What is that? Virtual register. This is not visible even the programmer and even the anybody. But we have the one registers there that we call as what the data in registers. What is this? Data in registers. Okay, data in registers. Through what the data in registers, it will communicate to the input devices to the processor. Similarly, if you want to communicate with the output devices, then the same address of that particular first next is what the same steps are there. Address of that particular that output devices has to be given. Next, control signal has to be activated. Control signal of that control signal has to be generated to the in order to communicate with the processor. Control signal of the that particular output devices has to be sent toward the CPU. Okay, next then if you want the control signal after receiving the control signal from the CPU, then definitely it has to communicate to the output devices through what the one register that we call as the data out register. Data out register. This is also virtual memory. This is also one of the registers which is present in what the output devices. This is a virtual register. This is not visible to any programmer, and even this is what the virtual register. Okay, this is these are the some steps. Okay, okay, this is all about the accessing of the IO devices. Okay, once again I am repeating this one. Accessing the IO devices. IO devices are connected to the each and every input and output devices connected to the, and even the processor is connected to through what the system bus. Here we have the three types of buses are there. One we call as the address bus, system bus, and also data bus. Okay, if you want to communicate with the any input devices, then the address of that particular unit, particular input devices or output devices, we have to send through what the address of that. Okay, we call this what the address bus. Address bus is what the unidirectional. Address bus is what the unidirectional, and also unidirectional. Data bus is what the if you want to do the operations as the read and write operations, then it has to communicate with the processor with the help of what the data bus. That is what the bidirectional. Okay, if you want to control these to be controlled by whom, the system bus. This system bus is also powerful, can also do the what the both operations, read and write operations, and also connected to the other operations connected to the each and every devices, so that the system bus is what the bidirectional. This is also what the bidirectional. Only the unidirectional bus is what the address bus. Address bus. If you want to communicate with the only the input devices, definitely address bus is to be used. If you want to communicate with the communication between the data bus, sorry, processor and the memory, any other units, with the help of the read and write operations ಮಾಡಬೇಕಾದ್ರೆ ಅವಾಗ system bus, sorry, data bus use ಮಾಡ್ತೀವಿ. Okay, that's the similarly the first steps for the input and output operations here. First is the step for the input operations. If you want to communicate with the input devices, I have the three steps are there. Particularly address, I have to send the address of that particular input devices from the CPU, that is the processor. Okay, then the control signal has to be generated from the CPU, that's the processor, and then it has to communicate with the input devices throughout the one of the register that we call as the virtual register, that is called the data in register. The data in register is not visible and even not available to the what the only the even the designer or programmer, but it is visible. It is be communicated through to the input devices with the processor through what the data in register. This register is used by only what the processor, not the if you want to communicate with the input devices. Okay, if you send any message, okay, if you send any data from the input devices, then definitely it will go to where in the first data in registers. From the data in register itself, it is converting toward the mnemonic code that is to be sent to where in the processor. In the processor, they are making the processor itself changing its value, what is the mnemonic code. If any character is there, that is to be converted toward the machine level language by the help of what the processor. Before going to proceed the any data from the input device, that is to be communicated through what the data in registers. This is present only what the in the keyboard, that's what the input devices. Next is what the steps for the operations for the output devices. Okay, so if you want to communicate with the output devices, then the particular address of that output devices has to be activated, send. Okay, then the control signal from the processor has to be communicated with to the sent to the output devices. At that time, the data out register is used for the communication between the processor and the output devices. This data out register is present in the where in the output devices. This is the virtual register. This is not visible to programmer, even the anybody, but this is to be used only by the processor in order to communicate with the what the output devices. I hope it is clear for you. Okay, take the copy the things whatever I written on the board. Okay, completed. Work on it.